Hello calculus students and general seekers of truth. Welcome to the video on improper integrals. And an improper integral has one of these two features. Either the limit of integration is positive or negative infinity, or the integrand has some discontinuities in it. So let me show you what I mean with this example here. So first, we want to find the integral of e to the negative x from 0 to infinity. And this is a somewhat intriguing example because e to the negative x rather, looks like this. Okay. So as x approaches infinity, this curve gets closer and closer to the x-axis. And the question is, well, if we add up all of this area onwards into forever, will this equal some finite number, or will it just continue to get bigger and bigger and bigger and bigger? And intuitively, it's really not clear. We would like to think that it approaches some number, and we would like to know what that number is, but it's not entirely clear. So we are going to take this problem, and the idea is to revise this integral using a limit. So we're going to take the limit, and I'm going to use a letter b as b approaches infinity, evaluating the integral from 0 to b of e to the negative x dx. Okay. So instead of putting infinity here, I replace it with a variable, and I'm taking the limit as that variable approaches infinity. And that's all we can really do, right? We can never actually reach infinity. All we can really do is see what happens as we get closer and closer to infinity, as the numbers get larger and larger. Now, this integral this antiderivative is not hard to calculate. It's negative e to the negative x. We're evaluating this between 0 and b, and we're taking the limit as b approaches positive infinity. Okay, so this becomes the limit as b approaches positive infinity of negative e to the negative b minus negative e to the negative 0. E to the 0 is just 1, so I can rewrite this limit as b approaches infinity. This here is minus a negative, so positive 1 minus e to the negative b. Okay. So what happens as e to the negative b, as this gets bigger and bigger? Well, we can think of this again as the limit as b approaches infinity of 1 minus 1 over e to the positive b. Okay. So continue on with our evaluation, and this is not good arithmetic. This is not what you want to write. You certainly don't want to write this on FRQ, but it's just for here in this lesson, good for you to see and understand. This is really 1 minus 1 over e to a very large number. Right? So you're taking the base of e and you're raising it to a ridiculously large number. So this term here is going to approach 0. So you end up with 1 minus 0, which is equal to 1. Okay. So amazingly enough, if we add up all of this area here between 0 and infinity, that area equals exactly 1. Alright, so we have that result, which is a little bit surprising, I think. Now, let's continue this idea and see a different problem. So I'm going to just kind of draw some messy lines around here. So 1 over x looks like this. Okay. And from 1 to infinity, so this is really the point 1, 1. And we're interested in what happens, what is the area of that curve right there. And we can apply the same concept as we did before. We are going to take the limit as b approaches infinity from 1 to b of 1 over x dx. Okay. So this turns out to be the natural log of x, the natural log of the absolute value of x evaluated between 1 and b, the limit of that as b approaches infinity. Okay. So this is the natural log of b minus the natural log of 1, and the limit of that as b approaches infinity. Now the natural log of 1, that's just 0. So the question is, what happens to the natural log function as b approaches infinity? So if you will recall, the natural log function looks like this. Okay. So as x, or b in this case, gets bigger and bigger, the whole thing gets bigger and bigger. So the result is infinity. But we can't just write this as our answer, so we say that this is divergent, or diverges, okay, as our final answer. In other words, this area here actually gets smaller and smaller as we go towards the right, okay, but the total area doesn't add up to any finite number. The total area, as we add on more and more, it approaches a very large number. Whereas this function here, e to the negative x, even though they look kind of the same, it's quite surprising, as we move further and further towards the right, goes down to a finite values. Okay? So these improper integrals can be quite surprising as to what their answer usually is. But this is the general method. Take out that integrand, replace it with a variable, and take the limit as that variable approaches infinity. Okay. So we've dealt with this case, and in the next video we will deal with this case where it has an integrand with discontinuities. Thank you for watching. Have a wonderful day.